The 2016-2017 VEX Starstruck competition is played on a 12x12 field. There's two alliances made up of two robots each. The scoring system, as you can see on the field behind me, there are jacks and there are orange cubes. The jacks are worth 1 point each when scored in the low scoring zone and 2 points each when scored in the high scoring zone. The cubes are worth 2 points each when scored in the low scoring zone and 4 points each when scored in the high scoring zone. The team that's able to lift up their robot, it's called a low hang, below the walls of the field, they get 4 points. If they're able to lift their robot above the walls of the field, they get 12 points.
All right, the elements of building the robot. First, we have to start off with our designing process, in which we look up and research different ways we can make this robot. Second part is what materials we might need for this robot and see how much we need of it. And after that, we start our creation and then look at our process and then just see our errors that we do and fix them, and then slowly progress to make it 100% good and perfect.
So at the beginning of each match, there's a 15-second autonomous period in which the robot operates by itself, completely without any drivers. So we actually code the robots to do whatever they're going to do, and we let them do it on their own. After that, there's 1 minute and 45 seconds of driver control, in which one of the students will control the robot.
It takes about like 6 or 9 months if you want to perfect the robot, but it just varies on what type of robot you want to build. For example, we can have a kind of like a forklift kind of robot, which just things back on it. You got scoopers, you got clamps on it. It's just different types.
So we have about 16 practice matches at the beginning of our tournament. After that, we'll have qualifiers. An average tournament ranges from 25 to 50 qualifying rounds. After that, the 10 best teams will be able to select their alliances. From there, they'll go into a tournament and eventually select the champion from there.
So the STEM program here at Eastwood, we have 2 pathways currently. We have the electrical pathway and we have the mechanical/robotics pathway. Here we have a demonstration of the robotics. You take concepts of engineering, you learn about all the basic stuff of engineering, and then you take robotics. You choose if you want to do electrical or robotics. If you choose robotics, you learn how to program robots, you learn about the sensors, and then your 3rd year you start learning about how to build and competition and more of mechanical aspect of it. Learn how to do engineering notebooks, more advanced programming, how to driver control, autonomous, where the robot is more things. Then you go into engineering math, and then this is where we go into more physics and start learning more about linear motion and torque and and more advanced stuff. So some of the benefits that you might have in joining the STEM program is that if you go to college, you have to take a computer science class. Well, the robotics class is a pretty good little intro into computer science and programming and stuff like that. You also learn how to CAD, so if you want to be a civil engineer or any kind of engineer that has to be computer design, we do some CADing in robotics, and we have more benefits in terms of, for mathematics, you get more real world scenarios.